So today we're going to be discussing Chapter 2.2, Quantitative Data. Our major objective is to organize quantitative data into tables and graphs. Please review pages 49 through 62. The objectives is to construct a frequency distribution for quantitative data. We'll also talk about relative frequencies within this frequency distribution. We're going to construct a histogram, and then we're going to determine the shape of a distribution from a histogram. So the first step in creating a histogram is creating the frequency table for the variable of interest. And so what we normally do for a data set is we sort it first from minimum to maximum. We then find the range value, which is right there, the maximum minus the minimum value. From this value, we determine the number of class intervals. The class intervals are over here. They're the first column in our frequency table. And this is more of a guess than anything else, but we want a number greater than 5, but less than 20. So we play around with that to find the right distributional pattern. So for example, if my range value was 50, and I wanted 5 classes, or actually something like 5 classes, then I would take 50 divided by 5, and the number 10 gives me what I call the interval size. The interval size is the range divided by the number in step 2. Then we set up the class intervals by the interval size. And we go from the minimum value typically, or we may pick a number a little less than the minimum, and we then go the interval size based upon that number that we calculated. Then, once we've set up the class intervals, then we go back to the data set, and we count the number of observations within each of the class intervals. So the class interval in the following example is the BMI from the data set that we had in class of 2016. And you can see that a determination was made for the class intervals. It turns out that I have 1, 2, 3, 4, 5, 6, 7, 8 intervals. They start out at 17 and they go up to 40. And then within that data set, in the class data set, I counted the frequency for each of the observations within the class interval. The other thing that we want to do within creating a frequency tables is to create a midpoint value and ultimately also probably a relative frequency column, right? So the midpoint is calculated by taking the lowest number. In this case, the first one would be 17, and we add it to the next lowest number in the next class, plus 20, and then we divide it by 2. In this case, it would be 37 divided by 2, which is equal to 18.5. And so here's our mistake. It's not 18, it's 18.5. So all of these now are 0.5, and we probably should make that correction on this video. And we'll show you what to do with that number when we get to the histogram. So our relative frequency, which we haven't talked about, we've talked about it in the qualitative data. It's the same idea. So for this value here, the 17 to 19 range, The relative frequency is 2 divided by 29, and 20, where did I get 29? The 29 is the total down here. So 29 observations in the data set. This is the relative frequency, and this comes out to be approximately 0.069, right, which is almost 7%. Same thing with this one. We could do the relative frequency there. And that one is 8 divided by 29, and that's approximately 20.276, right? So again, we can create a percentage. The relative frequency times 100% will give me a percentage. And so we could calculate this all the way down in this particular table. So from the frequency table that we have just calculated and computed, we want to create a histogram. And this histogram doesn't have any of the scales on it, which we're going to put on. So each of these points on the x-axis is my midpoint, right? So my midpoint is, like, here is 18.5, the next one is 21.5, the next one is 24.5, and it goes on up to the very end, which is 39.5. Make sure that your scales and your axes are labeled. This is BMI. All right, and the chart is class BMI 2016. Okay, so that's the sample that we're dealing with. Make sure that your scales are all evenly spaced for your midpoints. And then here's your y-axis, and your y-axis is frequency, right? So over on this side, we want to put frequency. Make sure you label the axes so we know what they are. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then, of course, we create the bars based on the numbers in the last table. Okay? So from the frequency chart, a midpoint was calculated for each class variable. We put that on the x-axis, right? So both of these are going to be included in that. The y-axis is the frequency, so this is our frequency side. And the histogram provides a picture of the center and the spread of the data variable. Well, in this case, this looks almost bimodal in a way. So there's our picture of the data set. Probably the center is somewhere in here, and our spread is somewhere along these axes here. Okay? All right. So it's important to, once we have the data set and we look at the distribution, we can see the spread of the data and how it relates to its center value. So the histogram determines whether the data set is symmetrical in relationship to its minimum and maximum value. It shows extreme values that can affect the center of the data distribution. So histograms can be skewed right or left, or may be symmetrical or bimodal. In this case, we have, the first case, we have a symmetrical distribution, and what we mean by symmetrical is that from the center there seems to be kind of an equal number of values on either side of the center of the distribution. That's what we call symmetrical, or symmetric, right? It doesn't always have to be a bell-shaped curve. This is bell-shaped in some ways. Sometimes we'll be calling that a normal distribution. Skewed right, here's an example of a very skewed right distribution. Right, it's skewed to the right hand, obviously. The center is probably right about here of the distribution, and you can see that the data moves considerably to the right. It appears considerably to the right of the center. That's why we say it is skewed right. Well, here are some other features that we want you to look at, right? Here again is kind of a symmetrical distribution, right? It appears that on either side of the center things are relatively even. Here it is skewed right, right? Skewed right. And here is something skewed to the left, right? Skewed left, right? And this is symmetric. I don't think that's how you spell symmetric, but we'll go with it, right? And then we also talk about the mode of a distribution, and mode has something to do with the most frequent observations, typically. So in this shape, there seems to be only one center of the distribution. That's called unimodal, and in this case, there's two potential centers of data, which we call bimodal. And it's not really two centers of data, there's only one center of actual data, but the most of the data is in two separate parts of the picture, so we call that bimodal. We can also have multimodal situations where multiple peaks can also occur. That concludes our discussion of Chapter 2.2 briefly. I would like you to look at problem number 24 on page 64. We will certainly be discussing that in class.